Every single second, we generate a massive, continuous flow of unstructured information. Millions of messages, images, and videos are rushing into servers globally. To an untrained eye, or even a standard computer program, this absolute mountain of information is completely meaningless noise. It is a chaotic flood of random pixels and digits. As humans, we naturally make sense of this through computational thinking. It is our biological cognitive ability to spot trends, filter out the distractions, and make logical predictions about what comes next. But we have a severe limitation. Our brains simply cannot manually process millions of data points at the sheer scale the modern world requires. Standard computers struggle with this complexity as well. They lack any inherent understanding of the real world, operating only through fixed instructions in endless loops. The solution lies in structuring data so that machines can learn to recognize patterns for themselves. Artificial intelligence represents the systematic translation of human pattern recognition into scalable mathematical logic. The first specific architectural mechanism AI uses to find order is a technique called classification. In classification, humans feed a machine a set of pre-labeled examples. By studying these examples over and over, the system learns the defining characteristics of specific categories. This diagram shows how this works. On the left, buckets of organized input examples, authentic and spam emails, feed directly into the central learning model. When the model looks at unread messages, it outputs a result, sorting emails into inbox and junk folders. The second machine learning mechanism, regression, shifts the process from sorting to calculating specific numerical values. Looking at this flow model, we can see how regression analyzes historical data to map how changing one variable dynamically affects another, which ultimately leads to a numerical future prediction. This chart shows two everyday examples of this in action. On the left, a model estimates future real estate prices based on size and location. On the right, it predicts a student's likely test marks based on their study time and past academic results. Both classification and regression are entirely dependent on humans doing the heavy lifting up front. We have to provide clear, historical, labeled data for the machine to study. The third and most autonomous method of pattern recognition is called clustering. This illustration shows how clustering works differently. Notice the funnel on the far left. It uses unlabeled data. The AI is fed a chaotic mix of shapes with no predefined categories. The machine autonomously compares characteristics to discover similarities, creating organized clusters on its own. This visual highlights real-world applications of this process. Meteorology systems group weather data into hot, cold, or rainy days autonomously, and your phone gallery automatically groups photos of the same face without you ever typing in a name tag. Clustering represents the pinnacle of this architecture, allowing machines to find hidden mathematical structure inside pure, unstructured chaos. Because these systems operate at such a high level, it is easy to view artificial intelligence as an infallible oracle. However, it is strictly a mathematical reflection of historical data. This exposes the core vulnerability of the entire system, AI bias. This occurs when the initial training data we provide is skewed or unbalanced. Take the early iterations of facial recognition software. These models were trained primarily on datasets containing examples of light-skinned faces. As a direct result, the system learned the pattern for light skin perfectly, but it suffered massive failure rates, sometimes up to 35% when evaluating darker-skinned faces. The algorithm mathematically replicates the blind spots of its human creators, operating exactly as it was programmed. This visual highlights the critical difference between two key terms. Look at the precision target. The arrows are tightly clustered, but they miss the center. A biased AI delivers results like this, consistent and precise, yet dangerously inaccurate because they fail to hit the truth. Because artificial intelligence is built entirely on the architecture of patterns, building truly intelligent systems depends on humans acting as ethical, responsible curators of the data we provide.